Hi, how are you doing, my secondary 3 class? We are doing 9-1 today. We're starting a new unit. Again, this is our packet. I'm going to try to scroll up here so you can see. The packet is, you can print it off, or you can go to the front office and then pick it up. It's a kind of a salmon color. But secondary math 3, unit 9, unit circle, we have 2 lessons we're going to talk about. Today we're doing 9-1 and however many parts it takes, but it's angles and standard form, degrees versus radians. So we'll be doing that today, and then tomorrow I'll set up your 9-2. So 9-1 are angles in standard form and degrees versus radians. I wanted to try to get the whole thing up here so you can see the angle and everything involved. Angles in standard form. So we previously have learned about angles, and angles look like this. Wait, how come? It was working a second ago. Come on. Oh, I have to be on the dot. Okay, so that's an angle. And the angle in the coordinate plane, like that, we see that it's in standard form when the vertex right here happens to be in the origin, on the origin. So when you have a coordinate plane like this, that means you're taking this angle and placing the vertex right there on the origin. And then one ray lies on the positive x-axis. So this right here is one ray. This is another ray on an angle. So if I move it up there, I really wanted, let's see if we can get a different color here. So if we move it there, this side moves to right there so that the vertex is translated to right there, and this initial side, one side is right along the x-axis, and then you have the angle right here that goes up to there, and then that other side lies also with its vertex at the origin. And that's this side right here. So we just translated the vertex to the origin, this side to the x-axis, and this side moving up however far it needs to go to accomplish the same degree measure as the original. So that's what happens when we place an angle on the coordinate plane, and we call that in standard form. So standard form, we see right here, standard form, and again, that's just what we talked about. We have an array right there on the origin. We move up, and then we have another ray that way, and that just kind of looked terrible, so I think I'll erase that. It's just going to be in the way, and we'll just make it blue. So we have the origin as the vertex at the origin. We have this side right here, and that's the side of a triangle, and we call it a ray, and this ray is the initial side. Sometimes I've seen initial ray, but initial side of the angle, and then this other side right here, this second ray, after this is traveled, this terminal side has traveled a certain number of degrees, then it occurs right there, coming from, again, the origin, and we call that the terminal side. And terminal means end, and so that's why it's called terminal side. It ends the angle measure and stops the angle from adding more degrees. So the ray on the x-axis is called the initial side, and then the other ray is called the terminal side. And I am sorry if you can't read that. You're going to have to just listen to my words, because I got a new toy. I can't write on it very well, sorry. So you notice that this side goes in a certain direction, and if we were to move around and around and around and around and around and around, we're going counterclockwise, aren't we? So those counterclockwise rotations, all right, if I'm moving counterclockwise that way, then that results in a positive angle measure. Now we have another little way we can go, and what happens when we go the other way is that we end up with a negative angle measure. And that's if we go clockwise. So if we're heading this way, like that, and we put our terminal side right there, then we would call that a negative, and that's 90 plus another 30, about negative 120 degrees. And those are negative angle measures. So moving upwards or counterclockwise and around, counterclockwise results in a positive angle. That would be probably about 120 degrees positive because we're moving counterclockwise. But when we move clockwise, then we end up in negative angles. All right, so that's key here. And that's weird because you probably haven't thought, I don't know, maybe you have, but it's possible that you haven't ever thought of angles being negative, a negative degree. But that happens, and that's what we have here. Now, if we go completely one full revolution all the way around, so we start here at the terminal side at the x-axis, and we move all the way around and end up again at the x-axis, then that's one full revolution. Moved all the way around, and that is 360 degrees. Okay? 360 degrees is one full revolution. So that's pretty cool. All right, those are all the information that we have about angles. We're going to try now to sketch them with certain angles, so we're going to draw them. If I have an angle with a given measure in standard position, then 75 degrees, what we're going to start with is the vertex and the initial side right there. And then we're going to move up 75 degrees. Now, we know, just as a little bit of information here, if I move up to here, that's 90 degrees, right there. And another 90 degrees is 180. So right there is 180 degrees. If I go counterclockwise, if I go clockwise, then it's negative 180 degrees, right? So positive 100, negative 180, and then right here as I'm moving along is another 90 to make 270 degrees. And then all the way around is 360. So 90, 180, 270, 360. And that's just some information on how we measure angles. And we have our initial side with our vertex, and then our terminal side is going to happen after we have rotated 75 degrees. Okay, it's less than 90, so it's going to be there in the first quadrant before we hit 90 degrees. So that's 75 degrees. All right, now we have another one that's negative 160. And I use a different color because it's negative. So because it's negative 160, I know that I need to start and move this way. Now that's 90, so we know we're going to traverse negative 90, and then we're not going to quite reach 180 degrees right there, right? Call it negative 180 degrees because right there is negative 180 degrees. We want to stop 20 degrees shy of hitting that 180 degree mark. So that would be right there. Hey. So that's going to be negative 180 degrees. And that's generally what people do to mark an angle. Okay, we have our initial side and our terminal side. And the terminal side is there right after we have traversed 160 degrees. And I don't know why I wrote 180, but I'm going to fix that and make it 160 like it should be. All right. Okay, 160, negative 160. All right, the next one is 140. 430, sorry. Now 430 is more than one full revolution. Remember that one full revolution was 360 degrees. So if I start here and I travel 360 degrees, I haven't quite reached our 430 mark. And the crazy thing about these angles is they can go on forever. You can just keep moving around and around and around and around and around. They are infinite. You can have an infinite angle measure or a negative infinite angle measure if you're moving in the clockwise direction forever and just keep going around. I mean, I could draw it for you. Negative can go around and around and around and around and around and around, and you can keep adding 360 degrees over and over and over again, or subtracting 360 degrees over and over and over again until you stop somewhere. So that's going to be 360 times however many times you went around, and then another, whatever that is, 30 degrees. Crazy, huh? So yes, we can have angles that are greater than 360 degrees, like we do in this case. So what I like to do is subtract a revolution from the 430 degrees, and that will tell me that will take away at least that 360 degrees so I can see what's left, and it looks like it's 70 degrees. So I'm going to move one full revolution for 360 degrees plus another 70, which is probably about right there, being that that would be another 90 at the y-axis there. So we're going to start at our terminal side. We're going to rotate one full revolution, and then we're going to come up another 70 degrees. Generally, we write what angle that is so that it's clear what we have moved for angle, and that's where we would put the 430 degrees. All right, so that is how we would draw angles and how we run through angles. Now we're going to talk about radians versus degrees. One radian, their way to measure angles in a unit circle or in a circle, and it's based on the arc length. Arc length is from here to here. All right, and what it is because we have a radius here, this is the radius, whatever radius is and whatever radius is, I would measure that and then linearly lay that along the circle. And once we lay those all out, then each of those is measured in 1 radian. All right, 1 radian. And generally, with the radius going right there, okay, the radius, this is the length, and then we would have another one, and then we would have another one. We always have, oddly enough, that's probably about right there. We have 1, 2, 3 radians plus 0.14 radians to get halfway around the circle right there. So it would be 1, 2, 3 radians, which is the length of the radius. It's just laid out in a curve until you get to right there, and then you have about 0.14 more to make it to right there at that point. And you might recognize that 3.14 as pi. And so right there is a measurement from the initial side over to this terminal side. That is pi, 180 degrees, because we've gone 3.14 distances around the circle to get to right there. And then we do another 1, 2, 3.14 for a complete turn around the entire circle as twice pi, 2 pi. So a radian is a unit of angle measure based on arc length, and it's the arc length that we're counting in terms of pi to know what degree measures they are. And they're not really degrees, they're radians, but they're defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So when this length right here is the same as this length, then we can measure 1, 2, 3.14, and we get to pi. And then 1, 2, 3.14 to get to 2 pi. And that is what a radian is. And it's kind of a crazy thing there, but recall that the circumference of a circle is 2 pi r, and we like to place r equal to 1. So we have 2 times 1 times pi, which is 2 pi, and that is the circumference of a circle. And that's how the radians are based on that. So 360 degrees is going to be 2 pi. That's one complete turn around the circle. And then 180 degrees, of course, is 1/2, and it's equal to pi. So that's how we come up with radians and degrees when we're working on circles. Now, you see 2 formulas here. So there is a way to convert back and forth. So if I'm in radians and I want to figure out what the degrees, the equivalent degrees would be for that radian, I would take the degrees that it is and multiply by pi radians over 180. And then if I want to find the degrees, I would set that equal to the radians and multiply it by 180 degrees over pi radians. And we're going to start I'm going to stop this lesson and start the next lesson with this part right here on degrees and radians, because our time is up. All right, well, stop this and just move on to part 2 for 9-1.